So I'll be presenting about the WAPlugin, which is a QGIS solution for accessing, validating, and analyzing FAO WaPOR data. Normally, this should be presented by the team that is behind this plugin, but this would have been a super nice occasion for them to be all together because they work in different parts of the world. But the Algerians didn't get their visa. It's very hard these days, so that's very sad. So Subida Nimar, she made the presentation, but we have Fabian here, Fabian Fonseca, who's one of the developers. So if you have more technical questions that I can't answer, he'll probably help us out. But let's proceed. So, well, you know, we are suffering from climate change, more variability. Some places get wetter, other drier, warmer, mostly. And we can see that also in the water balance. So here you can see that the depletion levels are increasing of the groundwater available. By the way, Subida made all these maps with the temporal controller, QGIS. And we can see also different water uses and how they're increasing. Lots of areas didn't have the data available, but it comes later in time. You see it comes available and it's increasing. Industry also a big user, but agriculture is one of the biggest users of water worldwide, and there's a need to feed, of course, all the people, and we need to achieve better management of the water resources for agricultural activities. And here you see a bit the overview of the consumption of water for different agricultural products, and I'm sure you know we have to eat less meat because that's a big water user, but even crops use water, and in dry areas crops need to be irrigated. So a lot of water is wasted during irrigation. It's not optimized. We have a lot of losses through evaporation. There is a non-uniform distribution of water in their application. There's wind drift, and there's losses through runoff. Also, the water is not always suitable to irrigate, so there can be pollution. And there, remote sensing and GIS come in the picture to come up with certain monitoring solutions for assessing the crop water stress, for example, to predict the crop yield, to monitor the climate and the weather, and to estimate the evapotranspiration. And there is now free data available already for some time from the FAO WaPOR database. And basically, they produce satellite-based products for monitoring agricultural water and production. And that data is used by many agricultural departments in the world for managing and monitoring their agricultural water use. So we're going to talk a bit about that. The second version of WaPOR, when the data got widely available, was launched on 17 June 2019 during the World Day to Combat Desertification and Drought. And the platform was an online platform which provides open data, which includes actual evapotranspiration, gross biomass, water productivity, and transpiration, amongst other data sets that are useful for people working in the agriculture and water sector. And the data has been provided at 3 different resolutions called levels 1, 2, and 3. And version 2 had data available from 2009 to 2023, and it covered only Africa and the Middle East. And the resolution levels were 250 meter, the continental scale, and then a national level of 100 meters, and subnational for certain selected countries from the WaPOR project have data for 30 meters available. And with IHE Delft, where I work for, we are the partner in this with FAO and organizations that provide the data to do capacity development and development of tools and dissemination of this product. And luckily, we are now in version 3 that was launched 4th of October 2023, and it has data available starting from 2018 and near real time. Coverage is the entire globe now at the level 1, 300 meters. So for any place in the world, you can get the data at 300 meters. There's a national data set still available for Africa and the Middle East, and subnational 20 meters for certain project countries, 20 meters. And you can generate that data also yourself with FAO WaPOR, which is open source, but we are currently training people to use it. But I guess soon you will have access to tutorials on how to use that and apply it to your own study area to generate the 20-meter data using Python. So for now, there are 2 websites that you can access. WaPOR 2 is getting deprecated, but you can still access it, and version 3 is in a new link. And now what the WAPlugin team did was provide a connection between WaPOR and QGIS through their plugin to make it easier for GIS analysts to ingest the data instead of going to the website and use online tools to select the data and clip and download it there in some formats, but to have a direct link with QGIS. And it has a very interesting story. The people who developed it are winners, and like Fabian, he was from the first team. They participated in a hackathon in 2020, and they won. So we organize hackathons to get more uptake and spin-offs of the WaPOR data. And in 2022, the first version was launched. And then there was a new team in 2023 which could also revive the plugin and brought their enthusiasm in. There was mostly the 3 people from Algeria. And they work with 2 developers, Akshay and Fabian, and they are still maintaining and improving and adding features to the plugin with all their enthusiasm. So the team consists of Akshay Donti here. The margins fall off a bit. Fabian, who's here, so you can speak with him. Subida, who prepared the slides and is more thematic, linking the technology to thematic issues and coming up with the features and testing it and validation. Together with Celia and Yassine from Algeria, and I'm guiding from the sideline. And of course, testing. So the WaPlugin can download WaPOR data from version 2 and version 3, but it can do much more than just downloading and clipping it to your study area. It can also compute irrigation performance indicators and water productivity indicators. And this is after you've installed the WaPlugin, how the interface looks like. So we have a user interface where in the first tab you can sign in for WaPOR version 2. For version 3 you don't need a token. So it gives you the links, and you can then get your token, save the token, so you not need to copy it all the time. And then you proceed with tab number 2 and fill in the parameters. And I think she made a nice animation in QGIS how that works. So after installing the plugin, you can open it, and then you can go to the portal to get your token with your account. And by the way, in the last time slot today, there is a workshop, and that will also let you do these things by yourself. I will present in one of the last slides a place where you can access it, even if you have another workshop today, or if you're watching from home, that you can still access the tutorial materials. So here we choose the WaPOR 2 catalog. You choose one of the resolutions. So here we choose level 3 or level 2. And you can set the time filter. There are different temporal resolutions that the data is provided. And the interface adjusts to those settings. So, of course, when you have annual, you only need the year. And when you have decadal, you also need the days and the months. And you can choose the time frame. And you can set that it has to be clipped through the canvas extent, or you upload a vector file, or you have that in the project. And you can use that as a clip polygon. And you can add a name for the layer. It will have a standard name, and you can choose the path, and it will add a part of the name to compose a file name. And then when you download, it will download the time series, and you can load each of these layers then in the map canvas, nicely clipped to the polygon of your study area. And you can browse your layers and open it there and check another layer. Yeah. Now for WaPOR 3, the newest data, it's a bit easier. You don't need a token. So you just go to the tab and you can then fill in the workspace WaPOR 3 and choose similar things as for WaPOR 2. So we will see that in action here in the animation, same study area. Go back to the plugin. It will load the available data when you load the tab. Make sure you have WaPOR 3. There are other data stores there, workspaces, but that's not relevant for the plugin. And you choose the layer with the resolution in time and space, which is added to the name of the layer. And you set the time frame that you want. Choose the vector file. Add a custom name for the TIFF files that it will output. And then click download. And then similar as with WaPOR 2, you can then load those layers. It will also show the WaPOR 2 that we had in the previous animation. And then when you load it, you can use that further for analysis. I'm going to go to the next. But it can do more, as I said. So there's also a tab for calculating indicators, which is useful for practitioners in the agricultural water sector. So it supports a list of common indicators, and it uses the data from WaPOR that you've downloaded, or if you want your own data in some way, but you need to be, of course, careful that it's formatted and that the units are in the same way as you need it. So, for example, there's the uniformity index, which measures if the water is evenly distributed in an irrigation scheme and gives you some results. And there's the beneficial fraction. It's a measure of the efficiency of the water farm and the agricultural practices. And the relative water deficit. So now with this tool, you can create easily these maps based on open data for your irrigation scheme. If you want to know all the details, please come to the workshop in the last session of today, and you will calculate these things. You also get a bit more context about interpretation and the equations that are used. And these are the productivity indicators. So the biomass water productivity is about how efficiently water is used to produce the biomass. So basically, biomass production divided over water use by the crops. And here we will see it in practice in animation. So we go back to the plugin. If I play it, yeah. And now we go to the last tab, the indicators calculator. We choose from the list the indicator that we want to calculate. And it gives you the equation that is used and a little description. And the interface adapts to what you need to use as inputs. And it uses the naming conventions that are already used when you downloaded it. So it will suggest you the layers that you can choose for the calculation. So here you see when we choose another one, it will adjust. And in that way, we can easily perform the calculations. And then when we run it, it will calculate, in this case, the adequacy indicator. Let's try another one, relative water deficit. You can easily calculate it. And there it is. And not all the indicators give spatial results. Some give also values. And I think this is one of those. Yeah, here you will see, you saw it quickly. It gave you the mean and the value, and it will give you an indicator if it's good or if it's bad. Yeah, and it limits the choices to the data that it needs, so you will not easily make mistakes. Yeah, here you see the values. Okay, well, you can try this again by yourself. So what are the plans of the WAPlugin team to implement further in this plugin is some automated seasonal aggregation. In the workshop, you will learn how to do it manually using r.series from GRASS. But it's a common practice in this kind of analysis that water agricultural people do, is to do this aggregation when they have daily or decadal data to aggregate it over seasons. Find bright spots and the gaps in the productivity in an easier way and visualize that. Making it feasible for users to add their own data for validation and compute validation statistics. Because global data is optimized for global use, but there's often need to check how well it works locally for the parcels. And yeah, two of the developers are also very much into AI, and maybe they could also enable automatic segmentation for field boundaries or other nice AI tools. Okay. So the workshop will be in the last time slot, but we compete with a lot of workshops. So if you can't make it, or you want to follow this later, or if you're watching at home, you can use this QR code. It's the first course style that is here now. Tomorrow there will be another one added to the GIS OpenCoursera platform. You can find a lot of free courses there related to open source GIS. And if you want to be in touch with the WAPlugin team, they're on social media, and yeah, they try to come to these conferences, and hopefully you'll meet them in the future somewhere. I know that Subida at the moment is trying to create an Algerian QGIS user group and maybe organize an event like this. So if she can't come here, we all just go there, right? So this was a presentation on behalf of the WAPlugin team.
All right, thank you very much. So, are there any questions?
Hi, thanks for the presentation. I have a question for the development team, or maybe you can also ask. Are there processing algorithms that come with the plugin, so you can use these tools as part of a workflow? Or if there's a plan.
I had the same question. We have been discussing it. The framework hasn't been designed for that, so it needs a redesign, but it's really an advantage for users. Or maybe, Fabian, you want to comment on that? It's also what we discussed earlier today.
Yeah, so officially we started with the intention of using the WAP data. So trying to help the users that actually need this data is our main goal. So feel free to reach out to us, any algorithm that you want to be included in the plugin. We're for sure open to implement it. For the moment, this is what we have implemented also on request, but we're always open to more suggestions.
Yeah, processing provider or like a tool in the processing toolbox would be really useful, because then you can create your own workflow in the graphical modeler, where you use the WAP plugin to download certain data sets, have your own workflows for calculating indicators or creating other types of outputs. So it's certainly something we will discuss to look at. Yeah.
All right, some more questions?
Thank you. I don't know if I catched it good, but I just wanted to ask: are there already like practical applications of this in the field yet?
Yes, we work with different countries in our projects where they use the WaPOR database, where people get trained at different levels, even using Python code to use the APIs to download stuff. But also, these are practitioners, so they really need it for monitoring their crop productions in agricultural irrigated areas. There are reports available also at the WaPOR website. You can find case studies, story maps, and all these things. So it is used, but we do our best to create more uptake.
Okay, thank you so much.
All right. Are there some more questions? Maybe I have one question. So as a developer, I'm always interested, how hard was it to develop this? Were you struggling with the team to get done what you needed in the QGIS plugin?
That's a good question. Probably Fabian can better answer, but I just want to say one thing. The biggest struggle that I saw was when they moved from WaPOR 2 to WaPOR 3, the whole API changed everything. So you probably encounter it the same as if you are developing plugins that rely on upstream things, that if they change something, then that's a hell of a job. So this team did really a good job to update it in the past weeks. There was not so much time. But Fabian, maybe you want to add?
Yeah, so as any project, the main point is how do you transfer the needs of the users into actually tickets that you can develop. And Hans and the team have supported us a lot, contextualizing what are the needs of the QGIS users into a workable product. And as Hans said, having to have this cooperation with the community, trying to find the gaps, who is the person responsible for a specific database, and how to use these endpoints. It has been the major struggle of the whole process, but yeah, the community is great. It support a lot on this process.
I think the QGIS community is very open and helpful. That's also my experience. But now you also relate to a community of users that are practitioners and that are not so used to open source, and also if they have problems, and the same is for big organizations, not to name them, and for the people who run the projects. Like if there's a problem, normally the information does not reach the developers. They don't use GitHub and file an issue, but they start discussing things among themselves. But things don't solve by themselves. They can be solved if they're clearly written in GitHub where the problem arises, what would be a potential solution, or well, what did you exactly do and what do you wish. And also these are volunteers, so they're not on a payroll of anybody to do that. But the first thing is the right information needs to reach them from what are the needs, what are the possibilities. So what Ujjwal said, it's also what my first thing was like, yeah, we need it as a processing tool so we can link it to other things. These kind of things are important, but also how the user, what do they struggle with that doesn't really reach us? And that's a question, how to get it better to us.
All right, we have maybe time for one more question, if there is any. But if not, then thank you very much, Hans, for your presentation. And we have a small gift for you.
I'll make sure this reaches the people who are not here in Algeria.
Yeah, so thank you.
Thank you.